Question 1 offers us a speed time graph. Speed on the y-axis, time down here. And we've got two children, Pat and Sam, P and S, and they're running along a straight horizontal track. Both the children start at the same time and finish at the same time. And we've got the two plots of their motion models here. So Pat accelerates at a constant rate from rest for 5 seconds and then reaching a maximum speed of 4, which she then maintains to the finish line. We're told the time that both the children finish the race, and now we've been asked to answer some questions on the model. And part A says, why are the areas under the two graphs equal? Well, the area under any velocity time graph is the distance. And as both the children have run the same course, they finish at the same time, they've run the same distance. So the two graphs, Sam's graph and Pat's graph, have underneath them the same area. That's a lot of writing for 1 mark. Also for 1 mark, find the acceleration of Pat during the first 5 seconds. Well, here is her acceleration. Time 5, eventual speed 4. The acceleration is the slope of the line. So here's the answer. Pat's acceleration is the gradient, which is the rise divided by the run. The rise is 4, the run is 5. And this is in meters per second squared. And that's your answer for part B. Part C. Find in meters the length of the race. So we've got to work out one of these areas. Well, the area we know most about is Pat's area. And that's the area I've marked in yellow. And I've also split it into 2 parts. One is half a right angle triangle here, and the other is a rectangle. Half the base times the height, plus, this will be 27 minus 5, and multiplied by the same height, which is 4. And if you work that out, you'll get an answer of 100 meters. And that's the answer to part C. Part D, we've got to find the value of x, giving your answer to 3 significant figures. So to work this out, we will need to equate areas 3 and 4 and make them equal to 100. And that will enable us to find the value of x. We need to know what this point is here. Well, we're told that Sam's acceleration is 1 meter per second squared, which means the gradient of this line here will be 1. Well, if the rise and the run are equal, this point is x. So now we can form an equation for the areas and make them equal to 100. Okay, the area of this triangle will be a half x squared, x times x. And that's the first element of the blue area. This is a half x squared. And the area of the rectangle will be 27.5 minus x multiplied by x. And we know this is going to be equal to 100. So multiplying all this out, I've got a half x squared plus 27.5x minus x squared. And that's equal to 100. So we've got minus x squared plus half x, so this is going to be negative a half x squared, plus 27.5x, minus 100 equals 0. If we swap all the signs, I've got a half x squared minus 27.5x plus 100 equals 0. And I've got my calculator set up to solve a quadratic. First coefficient is 0.5. This is negative 27.5, and we've got 100 as the number term. And I've got an answer of 55 plus 5 root 89 divided by 2. So x is equal to 51.085, and on it goes, or 3.915, and on that goes. Now, clearly x is less than 27.5, so we can reject this solution. So this answer is in range as it's less than 27.5 and lower than 5. So rounding the answer on our calculator up, to 3.92. I've got x is equal to 3.92 seconds, and that is correct to 3 significant figures as requested.